Hello there and welcome back. Let's continue our series on building a mathematical expression evaluator. In our past 4 videos, you have looked at the project setup in C++, how you've done tokenization, parsing, and in our last video we did a basic interpreter. In today's video, we'll be building on top of that to add some more functionality, specifically related to comparators. So by the end of this video, we should be able to handle tokens like less than, greater than, equal to, not equal to, and any of those comparators that is required for any mathematical expression. Let's get started. So in our last video, we left it at this point whereby we were able to evaluate expressions like 1 plus 1, and you will be able to get your answers as 2. And based on that code base, I did a bit of refactoring to kind of clean up some of the header files and the source files, just basically moving out most of the implementation details to the respective C++ files. So in today's video, let's begin from the top, the lecture.h here. And for this specific case, we need to add so I think we have equal to, not equal to, less than, greater than, less than or equal to, greater than or equal to. Yeah. So we think, let me add the representation here. Good. So we have equal to, not equal to, less than, greater than, less than or equal to, greater than or equal to. One more we'll add here, and we'll also have the one for. So I'll add for modulus first. Yeah, I'll do modulus in this section. That way. So let's look at how we'll be able to tokenize these ones, and then once you're done tokenization, we can now proceed to the parsing stage. So let's proceed down into tokenizing operators. We'll be doing it within this method. So let me switch to the C++ implementation file under the Lexa, and you have the tokenize method here. We should be having the tokenize operator here, and what we're doing initially was basically to get the current character which we are currently looking at the current index, and then advance the cursor to the next value. So what we need to do here is for the modulus, we need to check if we have the percentage sign. So what I will do, I'll copy that and then I'll paste it here again. Let me just format that. I also copy that. Paste it there. Format that. So for modulus, we'll be working with a percentage sign, and then this will be a modulus operation. Yeah, and then that's fine. So let's tokenize the comparators now, and for that I will still do else if here, and let me check if first of all the operator is equal to, let me put in quotes, let's start with the equal sign. So if the operator starts with an equal sign, so we are expecting to have the equal to, we need to get the equal to here like this. So for this specific case, oh, no, so we need to do this. So we need to ensure that this is dangling here. So we need to ensure that the next token available is also an equal sign. So I will put here if, and I will do pick if it's also equal, if it's same to the assignment operator. That means we have the previous token being an assignment operator and the next token being the same. So at this particular point, then we can pass equal to. So I will copy that, I will paste it here, and I will just change this to EQ. Change this to EQ as well, and then I'll change that to that. So we are checking if the current one is an equal sign, and then we check if the next one is the same, then we can have that operator. So I will copy this block because for the remaining part it's kind of similar. Let's begin, or let's do the not equal to. So for the not equal to, we expect that the previous token is a bang, this symbol, and then the current token or the current character should be an equal sign, an assignment operator, this one. So this will form the not equal to sign, and this will be the equal to sign. So if that's the case, I will just I'll change these ones here. So we'll be having the not equal to. I think also I need to change here, not equal to, and that's it for that. So let's come down here again. Let's do the less than, and for the less than, we have two options. When the previous character is a less than symbol and the current character is an equal to, then we need to pass here less than or equal to token, that way, that way. And if this is not the case, then we will be able to assume, we'll be able to actually not even assume, we'll just pass it as a less than symbol. So I'll just remove that and that. That way. So if the current character is an assignment operator, then we have here less than or equal to. Else we'll just pass it as a less than, because the current character is not an assignment operator. So the same applies for the greater than. So let me just copy that block. I'll paste it here. I'll do the greater than here. I will also do greater than or equal to. And the same applies here. Greater than token here. And that's it. So we will be able to get, let me change this comment here. For the greater than, we'll be able to tokenize greater than or equal to, less than or equal to, not equal to, and equal to, and then the modulus operator so far. I think that's all for this particular part. So if we come back to our tokens, we have been able to handle equal to, not equal to, less than, greater than, less than or equal to, greater than or equal to, as well as the modulus operator. So that's what you need to worry much in the lexer or the tokenizer part. Let's go to our parser, and our parser will be able to add new methods. Since we already tokenize all those new symbols, before we start passing additives, that is plus and minus, we need to pass the other methods first, that is I think I'm missing 2 more here. Yes, I'm missing 2 more. And for that, I'm missing the token or. I'm also missing the token and. And for this, just like how C and C++ does it, I'll use the pipe symbols, and then this is the ampersand symbols that way. So you're missing these two. Let me switch back to the lexa.cpp, and for these ones I will copy this, and let's actually put it at the top here. So for this, we expect that the previous character was the pipe symbol, and then the current one as well is the pipe symbol. If that's the case, then we'll be having the OR symbol here, and so here we can say the token is an OR, as well as yeah, it should also be OR, and then this as well should be able to be an OR that way. So if so that will work for that. Let's also duplicate this, and down here I will do the same for the AND operator. So change that to the ampersand, and then we'll just do here double ampersand, and then this will be the token AND. And here, and then similarly we'll be doing here the AND operator. So before we proceed to the next part about parsing, there's a slight problem that we've done here, and I think let's fix it before we proceed. So we are consuming some of these tokens, but we are not increasing the cursor index. So for instance, once you have this pipe symbol, we are picking, not advancing, and so down here we need to do an advance, and that's same for all of them, whereby we have that one as well. Also put it here, be here as well. So in the first one, where we can get less or equal to, greater or equal to as well, and that's it. That should cover it, so that's fine. So you can even collapse some of these ones into the same level, so that you can do else if, but anyway, that's fine. Good. So let's go into our parser. Then in our parser, let's let me duplicate that method, and then here as well, and then I will just start with passing the OR, and then once I have the OR, I can pass AND. Once we have the AND operator, we can pass the equality here, and then once you have the equality, we can now pass relational. So here I'll be passing the OR symbol, then next we'll be passing the AND symbol, then down the chain we'll be doing equal to and not equal to, For the relational, it will be all of them less than, greater than, less or equal to, greater or equal to. So in this the hierarchy will be, when you call pass expression, you'll be able to pass the or, then you pass and, then the equality, then the relational, and then once we are here, we can now pass the additives. So down this chain you go, the higher the affinity. So the lower it is, like the primary here should be the first priority, and then now you walk up. As you come up, the priority actually decreases. So for these ones, then let's implement them in our C++ file. So in our parser.cpp, where we're doing pass additives. So just before that, let's begin from the pass or. And for the pass or, it should be called here, and this should be pass or. And then for the relational, this is where now we should be. Okay, we'll come to that. So nothing is different here. So I'll just copy this block, and then I'll explain. Now I'll come here to pass or. I'll paste that in. So under the pass or, the left expression should be the pass and expression. And then while we are not at the end of the file, and then the token you're dealing with here is the or operator. So as long as we have more or operators, let's consume them. Then we consume the operator, which is or, and then also here we'll be passing the and operator, the and expression here. Yeah. And then we'll be making a binary expression, of course, because if you want or, then you'll be having part A and then you're doing or B. So we have the left expression, the right expression, and then the operator here is the or operator. So it's a binary expression. So we'll be having the left and the right. So by any chance, if the next operator here is not an or, then we'll not get into this loop, and that means we'll be having a left. We'll be returning the left down here, because the left will be the resultant of the pass and expression. So we'll be coming down this chain, and as we come down this chain, let me just still copy that. Let me paste it. So inside the pass and, we'll be calling here pass equality. So we'll be calling the next one on the chain. Let me put it that way. Let me also replace it here. And for the equality, we have two tokens. So I will add. So here, no, so under pass and, you'll be token and, so we will not be needing any other here. Let me just format it. Good. So we'll be checking if we have another and token, and if we have it, we consume the operator, we pass equality again. Once we have the left and right, to make a binary expression, and we return it down here. Similarly, that will be the same for equality, and here we'll be handling both the not equal to and the equal to operators. So we're supposed to call here the pass relational, which is down the chain, and also replace it here. Good. And now for the tokens, we need to check here. We need to check for equal to, or we also need to check, let me just copy and paste, for the not equal to. So if the token is equal to or not equal to, we consume it and we make a binary expression, and then we return that. Lastly, on this chain, let's have the relational. So for the relational, the expressions we'll be calling is the additives, and I will be putting it here and here. So we'll be calling the one down the chain. Since the additives, of course, it returns a unique pointer of a node, which is fine. But now for the tokens here, we need to check. I'll begin with the less than. I'll do less than or equal to, and then I need to duplicate the whole of this, and I will do here that way. So let me split them into new lines just for visual purposes. So this will be greater than or equal to, and that should be good. So all these squiggly lines is because these methods belong to the parser class, but we are not setting that here, so we need to add parser here, and that should fix the errors. Good. So less than or equal to, greater than or equal to, you get the operator, you pass additives as the right expression, and then we do the necessary. So that should handle everything to do with passing the or, the and the relationals, less than, greater than, as well as the equalities, and equal to and not equal to. The only thing I've not done here so far is to pass the modulus operator. So when you come to passing factors, where you're passing multiplication and division, you need to add one more here, and that's because modulus operators is on this level with these two mod op, yeah, and that should cover it. So when you be passing factors, we'll be passing multiplications, division, as well as modulus. That's done there. So let's now go into our AST. I don't think we'll be changing anything in our AST because most of the things you've added are basically binary expressions, so they'll be handled there. What we might need to add is how to do those comparisons, less than, greater than, modulus, within now the interpreter itself. And because the interpreter is kind of handling them within the nodes, so if I come down to our binary expression here, under eval, let's look at this evaluation implementation. So I'll come to ast.cpp, and then I'll scroll down to here. So we have this plus, minus, multiplication, division. So I will copy that, and then I will paste it a couple of times. Now let's do modulus first, and then we'll be able to do that. This will complain because remember we're using doubles for our numeric types, and for doubles we might need to use a different method for that. This will throw an error because I think for this symbol it expects integer types, not doubles. So let's do here equal to, not equal to, and I will do return equal to, not equal to. And then we'll do greater than. So we have greater than or equal to, then we'll have less than or equal to, so we have equal to, not equal to, greater than or equal to, less or less or equal to. I think we've done all of them because we have the equality here, then you have the relational here. Good. Then you have the modulus here. Good. So let's implement these ones. Let's implement them within the runtime var struct. So let me save this. Let me come back to backend, and then we'll be doing runtime. In the runtime class or struct, we had implemented these methods here, and I think let's see if we can implement for the rest. So we've done that. Let's do here for modulus as well, and then okay, so we've done modulus, and then let's do equal to. Let's do not equal to, and then let's do now for the relationals greater than. Let me just duplicate that. Greater than or equal to, less than or equal to. I think that should be all because you have good. So we have added these new methods, so we need to implement them. So let's just copy. Let's save that. So in our runtime.cpp, I'll come down here and then I will paste them. So let me first begin by handling this one. That way we can have some intelligence working in our favor. So let me just put it there. Good. So we need to add the body, and then we'll just do the implementation by copying and pasting what we did in our previous video, and just changing to suit the operation, and that's done. So for division, I will just copy what we did in division, and then for modulus, I'll paste it there. So similarly, it needs to be numbers on both sides, and then if that's the case, we need to do fmod. I think so. Yes, we need to do std fmod, and I think that will and then this one as well. So it takes two double parameters and then it returns another double. Good. So that's what I wanted. And then I'll just replace it here. and then I'll remove the new line. So we'll not be using the percent symbol that you're used to because we're dealing with doubles, but fmod should work for that. Let's do next equal to. It should be similar to what you've done here, the only difference just being the symbol you have used. And this unfortunately will work for most data types, not just numbers. So here we need to ensure that if it's a number, then equal to. There's no need to convert. I think what you can do, because I think in the runtime var, let me just go back to header. We are storing the type, and then at the same time we're storing the value. So if the value is the same, so I think I can do value is equal to other dot value, and we need a semicolon here. Good. So by time we are crossing this check, that means it's either both sides are either strings, numbers, because we have, what if somebody does nil is equals to nil? It should result to true. It's like false is equals to false. Good. So I think we don't even need to throw an error here anymore. So explicitly, if the data types are not the same, we throw an error here. If that's not the case, we just compare them and return the result. As simple as that. And that should handle that. Now, with the equal to done, the same will apply with the not equal to. If you try to compare a Boolean to a string, let's just throw an error for that. Yeah, let's just throw an error. And here will be not equal to. Good, that's fine. Operator greater than, let me just paste that. And for the greater than, this should apply only to numbers and strings. Yes, because in C++ you can compare strings. I think that's a comparison of the length, if I'm not wrong. So we can leverage that. So let me do here or string. I don't think we can do for Boolean and null values. We can't do it for number and strings. So let's limit that there. We might come to change this later, but anyway, let's just implement it first that way. And we might need to convert it to strings. or to float and double. Okay, we'll come to confirm that once we run and confirm that the results are not matching. So let's leave it as a to-do task. So we need to be updating the operator here. Similarly, the modulus operator here. Okay. So the same will apply for the remaining methods. Let me just copy and paste, and we'll be shortly. Right, we'll be back shortly. Good. So you've done the copy and paste for greater than or equal to. They've done less than or equal to, and that covers all the operators. So let's save this file. Coming back to ast.cpp, and of course our the errors have gone, so we are good to go. So let's just run this to see if everything worked as expected. Let me exit from the current REPL, and then we'll run our program. Okay, so let's do 1 is equals to 1 is true, 34 is greater than 12, 25 is less than 12, it should be false, which is fine. Hello is equals to hello, which is true, and do hello is not equal to hello, which is true. So we have, let's also do 6 modulus 3 should be 0 because it divides perfectly. But if we do 4 modulus 3, it should give you an answer of 1, which is correct. We do 12 point, so we are not currently supporting decimal points, so that's fine. So we have been able to do that. So if you do a complex operation, like if you do 23 plus, and let's do 78 modulus 13, all that you multiply by 0.5. Oh, so I keep forgetting you're not supporting decimals yet. So let's just do 1 divided by 2. That will give us 0.5. So the answer is 23. So that's fine. So far we've been able to see how to implement all that. From our previous video, there was an issue, and let me just show you. So if you do here 6 into, let's say, 1 divided by 2, so the answer here should be 3, because it will be like 6 times 1 over 2, which is 6 divided by 3. Let's see what it gives us. It says actually the answer is 0.5, which is wrong. So it's supposed to evaluate the inner before it does this one. So this issue is actually called, I think it's called implicit multiplication. So this should actually evaluate to 6 times 1 over 2. And that should be 3. So anytime you have brackets followed by any other thing inside of it, so if there is no operator in between the brackets and what was calling it, then it should implicitly assume it's a multiplication. So it's a small issue. We'll fix it in our next video. I hope we found this this video informative, and I will see you in the next video. Bye.